after learning the previous three parts, you must have been familiar with the structure of modern IoT application, how to embed internet services, and Azure IoT Hub and its usage. Very, very familiar with them. In this chapter, I'll introduce a very practical case, and then consolidate what we've learned before, as well as add some contents of Ruff app development we've learned before into this application, so as to realize speech recognition to control the turning on of a light. And our course objective is to control the development board through speech sounds to later turn on or off the LED. When we say turn on, the LED on the development board will be lit on. When we say turn off, the LED on the development board will go off. To start with, let's look at the part of speech recognition. As for the speech recognition service, we select the online speech recognition of Baidu, a cloud service. Its functions is to convert speech sounds into texts. We might have a look at the lower right corner. Its input is an audio file in the WAV format. Sure, it also supports other formats. Here, our cases mostly adopt audio files in the WAV format, and its output is to feed back to us the corresponding text of this audio segment. The middle part tells us how to register the service and how to use the service. Let's skip the details. The following is a simple instance of using this service. Now, let me guide you to look at this code segment. First, we need to download the SDK to the local. After downloading it to the local, we first require this SDK, and then get an object. Next, let's add three crucial parameters after creating the application, namely app ID, API key, and CK key. Add these three parameters here. And then we new such an object, and then get a client. Next, we call the FS module to read an audio file named test.wave on the disk. Let's call client.recognize to complete the speech recognition. After successful speech recognition, it will be called to a callback here, and we can get the result. This process requires the guarantee of the current PC being connected to the internet. As this API is being called, the data in this wave format is uploaded to Baidu Cloud, and then Baidu Cloud sends them back to us after processing them. The next part is audio recording. As we discussed just now, the input of speech recognition is a wave audio file. Then, how can we generate this wave audio file? Here, we mostly rely on an NPM module, and it allows audio recording under Mac OS. For details of the steps, we may refer to the middle part. Here, let us have a look at one of its instances in actual use. At first, I call FS. Next, create a writing stream, and then its path. It's just such a test.wave file. Now, let's call record.start. It triggers off the microphone on our Mac to acquire the current speech sounds, and the sampling rate is 16,000 Hz. When the sampling is finished, it saves it to the test.wave file, and as we see here, the acquisition is completed in 3 seconds. This file saves our recorded audio on Mac. Next, we'll improve the audio recording part and the speech recognition part into a whole. Its input is our audio, and its output is the text. On the left is the improved code. Let's skip the details. After we get a recognized text, how can we control our development board to turn on the light? At this time, we need to integrate the IoT Service SDK, which we mentioned last time. Here, let's have a look at the code segment above. If we get a result, which means turning on, we will send an on event to a corresponding device, and the logic between them relies on the IoT Service SDK, whose detailed usage was introduced in our previous lesson. In fact, what it calls here is a function, send message. As for its specific action, we may refer to the code segment in the lower part of the screen. If the recognized text means turning off, we will call send message off, such an API. The first part, one is for speech recognition, one is for audio recording, and another is for sending the command to the cloud. And the three are integrated as we see in this block diagram. At first, the Mac acquires the audio, and it generates a WAV audio file. Then we upload the audio file to the Baidu cloud for speech recognition. The result of recognition is the text corresponding to the audio, and then we add some conditional judgments. Call Azure IoT Hub Service SDK to send the command to our final IoT device terminal. That completes a block diagram of the entire case. No doubt that the left is what I call the display control front end. Then, the Ruff Development Board, which actually serves as a terminal for acquisition operation. Well, how to develop at the device end? Here, we select a real development board for that, instead of a PC command line for simulation. First, create a Ruff application. So, just create an empty application with wrap in it. Next, add Azure IoT Device SDK. Here, we may use wrap install Azure IoT Device mat, such a command, to add an Azure SDK to the application. Next, write the application. Later, I'll lead you to see the application code we've written. Step 4 is to configure the network, since throughout the execution of the entire case, do ensure that the development board be available for connection to the internet, so that it can access Azure IoT Hub. Then, how can we enable it to connect to the internet? It should be set up with Wi-Fi. Here are the specific procedures. To start with, when the development board is powered on, it actually enters an app mode. And when this app mode has been launched, we enter our configuration interface in the browser. Type in the IP 192.168.78.1 or an address, that is console.ruff.io. After entering it, at the configuration interface, we can configure this network. Type in SSID and the password, and then submit. After half a minute or so, we log into this configuration interface again, and now we can see the allocated IP, which proves that the current Ruff development board can be connected to a router, and it can access the internet now. Upon successful network configuration, we can deploy the application to the development board and execute it. This application has indeed been successfully deployed. Here, let me first check the current Ruff development board. Its IP address at the connected Wi-Fi, which is 172.20.10.11, and check its log. View its application code first. Here, let's first see where the Ruff application code is. In fact, we discussed most logics in the previous lesson. Here, we just briefly recall them. First, here, I add the connection strings of the Ruff node device. Note that it is not the connection string of IoT Hub resource instance here. Then, let's create a client, and then originate the connection. If the connection is successful, it displays successful connection. Here, it does the on message event. When an event is received, let's judge whether it is on or off. If it is on, it turns on the red LED. If it is off, it turns off the blue LED. Next, let's deploy this application onto the development board. Now, let's look at the code on the PC. This code actually integrates the three parts I mentioned just now, which are the functions of audio recording, the functions of using the online speech recognition service of Baidu, and another is the function of, with Azure IoT Hub Service SDK, sending a command. Let's briefly look at them. First, record an audio, and it is saved. This audio is saved in the command.wave file. 3 seconds. As we see here, in 3 seconds, the audio acquisition is completed. And then we call the relevant APIs of Baidu to recognize this audio file. After successful recognition, it enters this content. And then we will judge whether it is turning on or turning off. If it is turning on, it sends on. If it is turning off, it sends off. This can be linked to the Ruff application. We discussed this just now. And Ruff just happens to judge whether the received command is on or off. Let's view at the left terminal, the Ruff Development Board. Next, let's view the log on the Ruff Development Board. And do speech recognition here. Turn on. As we see, this log has displayed the result of speech recognition and successful connection. Successful sending. Now, as we see, the blue LED on the development board has been lit. We execute turning off. Similarly, we see the result of speech recognition is turning off. Successful connection. Successful sending. Now, as we see, the blue LED on the development board has gone off. Alright, so that's all for this lesson. So please look forward to our upcoming classes on Ruff. Thank you very much.
Ruff, make IoT easier.